let's just take a moment to look at our syllabus calendar. So we're on class 2. We're going to talk about modeling sets and absolute value today. And then I've got some upcoming things highlighted here to keep you reminded of due dates and stuff. So your first project is due on February 5th. And the material that it covers, we're going to go over on Monday. So I will hand it out to you today, just in case you want to play around over the weekend and get a head start on it. But don't feel like you should know what you're doing yet, right? So after Monday's class, you'll be like, oh, okay, I know how to do that project. And then your first take-home quiz, I'll give you Wednesday. I'll give you Monday, and it'll be due Wednesday. So that's coming up next too. All right. So just to remind you, when you come into class, the very first thing under any class number is preview exercises. So that's what you should be working on for the first 5 minutes or so of class. Anybody done? Like 2 or 3 people? Okay, so why don't we take like 2 more minutes and people can finish this up, and then we'll start the demo. Okay, so we were looking at some data about the cost of tuition and fees at public 4-year U.S. colleges. Okay, and you might have some observations and some questions. Okay, so the good news is that it may be possible to answer your questions using mathematics. So we can work with the real data collected and presented in the bar graph to try to find a mathematical model, or more simply just a model. A model is a mathematical representation, like an equation or a formula, of a real-world situation. So if you can describe the relationship between 2 or more quantities, you can write an equation relating them. And this is an important step in problem solving, being able to convert a description of a situation into an equation. So let's use math to answer some questions about the cost of tuition and fees using a model. Okay, so here's a formula that models the data. T for tuition equals 4x squared plus 341x plus 3,194. T is tuition, X is years after 2000. So I want to use the formula to find the average cost of tuition and fees in 2010. Okay. So they're asking me to find tuition and fees, and they're giving me a year. Right? So which am I going to be plugging into, X or T? X. Okay. And what am I going to plug in for X? 10. Why just 10 and not 2010? Yeah, because the way we defined X, right? X is the number of years after 2000. So 2010 represents 10 years after 2000. So I'm just going to put in, instead of all my X's, I'm going to replace them with 10s. Okay, and I could probably do that in my head, but I'm going to pull up my calculator. Okay, so let's see, 4 times 10 squared plus 341 times 10 plus 3,194, and I get $7,004. Okay, so by how much does the formula underestimate or overestimate the actual cost from the bar graph? So if we go back to the bar graph and look at 2010, the actual value was 7,020. Okay, so this is the actual data, right, collected in the real world. The actual cost was $7,020. So my model is what? Too high or too low? Too low. So my model underestimates real life by how much? $16. And when we're talking a price of around 7,000, it's not a bad percentage error, right? $16 doesn't seem like that big a deal when the actual cost is 7,000. So it's a pretty good model. So far, seems like a pretty good model. Let's see what happens if I try to predict for 2014. So this time, instead of putting a 10 in here, I'm going to put 14s. So I'm just, instead of 10s, changing these all to 14s. And I get 8,752. Seem like a reasonable estimate? Went up, which we expect it to do, right? Yep. All right, 1990. What should I put in for X to represent 1990? Negative 10. Yeah, 10 years before 2000. So I'm going to put in negative 10. So I'll do this again. Negative 10. And I got to put in a parenthesis. So I've got negative 10 squared plus 341 times negative 10. There we go. And we get 184. $184. Okay. Does that seem plausible? I heard a couple of little chuckles, right? $184. It does not seem plausible, right? It seems too low, right? For only 10 years before the year 2000, right? And in 2000, it was almost $3,400. Just 10 years before, they're saying it was not even 200. So it seems like way too cheap. So I'm going to say no. Seems too low. All right, so sometimes a model, if you extend it too far beyond the given data, so our data went from 2000 to 2010. When we went out to 2014, seemed fine, didn't seem anything crazy, but when we went back to 1990, we got kind of a crazy answer, kind of an unreasonable or nonsensical answer. And in those situations, we say that we have model breakdown. The model just doesn't work anymore, so we call it a model breakdown. So just as an aside, the College Board reports that the average yearly cost for tuition and fees and room and board at a 4-year private school was about $40,000, up 14% over the past 5 years. For public, it's $18,000. Yeah. What? Yeah. Yeah, there are certainly more expensive ones. And this was 2013-14. The percent increase is really fast. 14% over 5 years, 20% over 5 years. It's going up fast. All right, so we're going to make a transition to a slightly different topic here. We're going to talk about sets. And a set is just a collection of objects. So for example, we could have the set of students in this classroom, the set of large species of cats, the set of Oscar winners for Best Actress. The objects in a set are called the elements of the set, and we might write a set by listing its elements between curly braces. And when you do that, that's called the roster method, where you just put curly brackets and you just list everything in the set. So for example, we could let A represent the set of the Three Stooges, right? So in this case, we would write A equals, and then in curly brackets, we list Larry, comma, Moe, comma, Curly. And then another example, we could let set B represent the set of the 4 Beatles that arrived at JFK Airport in 1964. So if I was going to list them, I start with curly brackets, and then who's in the set? John, Paul, George, and Ringo. Yeah. John. Good. So those are the 4 Beatles. Okay, we just list them out in between curly brackets. So the sets we encounter in this class I don't know, depends on your perspective. More or less fun than listing the Beatles. I don't know. But they're typically going to be sets of numbers. So we're going to use a couple of different methods other than just listing them out, because often we deal with sets that have infinite numbers of things in them, infinite number of numbers. So you can't write them all down. So we have a couple of different things that we can do to represent sets of numbers. We can do set builder notation, interval notation, or a number line, a picture. So set builder notation is a descriptive way to write a set. It generally looks like this. You start with a curly bracket, just like you were going to list everything out. And then you write X, vertical line, and that vertical line is read as such that. So far we would read this as the set of all X's such that X meets some conditions that you would write, you choose. So for example, if I write this set in set builder notation, I would read that out loud as the set of all X's such that X is greater than 2 or bigger than 2. So on a real number line, I would graph that by shading all the numbers that are bigger than 2. And I'm not including 2, it's strictly bigger than, and when you're not including 2, you put a round bracket on the number line. If I wanted to include 2, I would put a square bracket on the number line. Okay, so finally, I can put this in interval notation where I put 2, infinity. Okay? That means start at 2 and all the numbers up to infinity are in the set. Again, round brackets mean that you don't include the endpoint. So I don't include the 2 because it's only numbers bigger than 2, not or equal to 2. And I don't include the infinity because infinity is not actually a number. You can't ever get there. Like if you're counting, you would never go, and infinity, right? So we can't put infinity in the set because it's not really a thing. So infinity always gets a round bracket. Square brackets would mean include the endpoint. So let's do a couple of examples. I've got a couple of number lines here that are shaded, and I'm going to translate them to interval notation. So what's the smallest number in this set that I have shaded here on the left? -1. Is it included in the set? Yes, so I put a square bracket on it. And then I put comma. What's the biggest number in this set? 4. Is it included? Yes, square bracket. And it always goes left to right, smallest to biggest, just like it mirrors the number line. Smaller numbers go on the left. Okay, this number line on the right here. What is the smallest number in that set? -infinity. Great. There is no smallest number. It's shaded all the way to the left forever. Okay, so that is -infinity. Round bracket or square? Round. You always put a round on infinity. And then we do comma. The biggest number in the set is 1, and it's included, so I square bracket it. Questions? Okay. So that's it for the lecture part. You are going to spend the remainder of class working through this class activity. And then if you finish all of this, we didn't even get to the class activity last class. So if you finish all of this, go back to class 1's class activity, which was the review of the prerequisite material, and start that.